Hi everybody, this this lesson is some extra information about finding the inverses of 3 by 3 matrices in response to some specific problems that have been found to be very difficult because of some little kind of tweaks on how the program might want you to enter your answer. So sometimes they want you to find the inverse and then at the very end factor out a GCF in order to match it up to one of their answers. So I want to show you how to do this. That way you will be able to get those questions correct. So I've already taken my A and I've augmented it with the identity matrix, and we're going to go ahead and go through and row reduce this. I also have already put this augmented 3 by 6 matrix in my graphing calculator. So go ahead and take a second, pause, and do that in order to get started here. Now we want to row reduce this matrix, so I need to start by turning this 4 into a 1. So the first thing I'm going to do is take 1/4 of row 1 and make that my new row 1. In doing this, the rest of my rows will stay exactly the same, so I'm just going to go ahead and fill them in. And the only thing that's going to change is row 1. So I'm going to do a second matrix, and I've got it already in my matrix A. So I'm going to go ahead and do a times row there. So I'm doing 1/4. So 1 divided by 4, comma, where am I doing this? Second matrix A, comma, and we're doing this to row 1. And then remember always to close that up and then store it back in matrix A again. Okay, so I've got my new top row, and if you want to keep everything as fractions because it'll be easier to figure out what to multiply by later, remember that you can always at this point do a math and turn it into fractions. So my first row across the top is a 1, 7/4, 3/4, 1/4, and the other two entries are zeros. So I turn that top leftmost entry into a leading 1. Now we need to turn the rest of that column into zeros. So it looks like I need to take that 1 in row 1 and just add it to row 2. The 1 and the negative 1 will cancel out, leaving a 0. And then I need to take -2 times row 1 to add to row 3 in order to turn that +2 into a 0. And that will be my new row 3. So again, at this point, I'm using row 1 to change the other row, so row 1 just gets copied. Okay, so let's go back into our calculator. We're going to do second matrix math. This time we need times row plus. In the first one, we're doing a multiplication of 1. We're doing this in matrix A. We're doing it to row 1 in order to change, so that looks like a subtraction, in order to change row 2. So we put 1 and then 2, close it up, store it back in matrix A, and then I'm going to do a math fraction to look at that as its fraction form. So my middle row now looks like 0, 7/4, 3/4, 1/4, 1, and 0. Okay, let's do that next one where we're going to do, second, quit, sorry. So now we're going to do a second matrix math again, times row plus again. This time, delete that, there we go. This time I'm multiplying by a -2 in matrix A. We are doing this to row 1 to change row 3, close it up, store, back in matrix A. And again, so that I can see my fractions. My bottom row is now 0, negative 13 halves, negative 5 halves, negative 1 half, 0, 1. Okay, we need to get our next leading one, so we go down to this element right here. We want to turn that into a positive 1. So it looks like we need to do times 4/7 into row 2 for our new row 2. Again, at this point, right now, rows 1 and 3 are not changing, so I'm just going to copy those back down. And this bottom row that we just got, I'm going to copy it back down. Now I need to multiply that middle row by 4/7. So I'm going to do a second matrix math. This time we just need times row. I'm going to do a new parenthesis and say we're multiplying by 4/7. Close that up, comma, we're doing this in second matrix A. And what row are we doing this to? We're doing it to row 2. Close it up, store it, back in matrix A. And that looks really ugly, so we definitely want to turn that into fractions. Okay, so my middle row now looks like 0, the 1, which I wanted, so that's good, 3/7, 1/7, 4/7, and 0. Now we want to change these other two entries above and below that new leading one into zeros. So it looks like I need to do a -7/4 row 2 plus row 1 for my new row 1. And I need to do a positive 13 halves row 2 plus row 3 into my new row 3. Using row 2 to do this, so row 2 copies down. When we do these calculations, I'm going to start, just to save time, I'm going to do these calculations on the side and just tell you what you should get. So follow along with what you should get. For your new top row, you should now have a 1, 0, 0, negative 1, or sorry, 0 here, negative 1, 0. And for your bottom row, you should now have 0, 0, 2/7, 3/7, 26/7, and 1. So I'm not going to show all the row operations in the calculator to save some time. Now I need to change my bottom right entry on the left-hand side into a 1. So I need to take 7 halves times row 3 and make that my new row 3. Rows 1 and 2 are not changing yet, so I'm just going to copy those back down. Okay, and when I take this bottom row times 7 halves, I'll get 0, 0, and the 1 that I wanted. Then I'll have 3 halves, 13, and 7 halves. Now the very last thing I need to do is change the rest of that third column into zeros. Lucky for us, the top entry is already a 0, so really I just need to change this 3/7. So I'm going to take negative 3/7 times row 3, add that to row 2 for my new row 2. Okay, so row 1 is finished. Row 3 is finished, so 0, 0, 1, 3 halves, 13, and 7 halves is done. And my middle row now turns into 0, 1, 0, like we want. And then we have negative a half, negative 5, and negative 3 halves. And now what is on the right-hand side in this augmented matrix is in fact the inverse of A. And we could theoretically stop here. However, on some of the questions online, this is not going to be an option. And what they're wanting you to do is they're wanting you to, for some reason, they would prefer for you to give that answer as all whole numbers in the inverse matrix with a fraction pulled out. So what happens here is we want to, in this case, factor out a 1/2 because the 2 is the denominator that all of these fractions have. If it had 4 denominators, we would divide out a 1/4. So we want to divide out that 1/2, pull it out so that all of the entries in the actual matrix itself are whole numbers. Remember that dividing by 1/2 is the same thing as multiplying by 2. So if we want to pull this 1/2 factor out, what happens then is that every entry in there gets multiplied by 2. So if I go across the top row, I'll have 0, -2, and 0. If you multiply a -1/2 by 2, you get -1. -5 multiplied by 2 is -10. -3/2 multiplied by 2 is -3. 3/2 multiplied by 2 is +3. 13 multiplied by 2 is 26. And 7/2 multiplied by 2 is 7. So this should match up to one of the answer options that you're given online. So that's what they're doing. It's just this extra step of wanting to make that matrix part a little bit cleaner by pulling out whatever fraction they all have in common, turning them all into whole numbers.